Welcome back to this video tutorial. We can discuss about the method of finding the transpose of a given matrix here. Okay, so first of all we need to understand what the transpose of a matrix is. So this transpose of a matrix is the flipped version of original given matrix. Flipped means we need to interchange the rows and columns of the given matrix. So consider this example. Here it is a matrix A with number of rows equal to 2 and number of columns equal to 3. Okay. So the values stored in this matrix are 1, 2, 3, 4, 5 and 6. So after finding the transpose means what? The flipped version of the original matrix. That means we need to interchange the rows and columns. So in the transposed form, the transposed form of this A, number of rows equal to the number of column of the original matrix. So number of rows here equal to the number of column of our original matrix, that is equal to 3. And number of column of this transposed version equal to the number of rows of the original matrix, that is 2. Okay, and this is the transpose of the given matrix. Okay, so 1 is present at index position 0, 0. And here the 1 is present at the same index 0, 0. And this 2, the first row, second element 2, the index is 0, 1, which is present here in the index location 1, 0. Okay, the third element of the first row, that is the index is 0, 2. The 0, 2 index pointing to the value 3 here. Now the 3 here pointed by index 2, 0. From this it is clear that we need to interchange the row and column values here in this transposed version. Once more we can consider this 4 is present here in the index position 1, 0 of our original matrix. The 4 here comes at index location 0, 1. That means the I and j value or the row and column value get changed. Here this 4 is present in second row, first column. Here that means the first row 0, if the index is starting from 0, then this is the first row, this is the 0th row, this is the 0th column. Okay, so this is the 0th row, this is the first row, this is the 0th column, this is the first column, this is the second column. So this one 4 is present here in first row with 0th column, but here it is present in 0th row with first column. That means the row and column index of this 4 get changed here in this transpose. Okay, so the two condition we need to attain in order to get the transpose of a given matrix, that is we need to change the row with the column dimension and the transpose form, and the column dimension is changed with the row dimension of our original matrix. And for each of these elements the index position gets changed with the row index with column index and the column index with the original row index. Okay, so we need to follow or we need to consider these two conditions in order to get the transpose. Once more, we need to change the row size with column size of the original matrix and the column size with the row size of the original matrix. And for each of the elements we need to change the index position, that is the row index is changed with the column index and the column index is changed with the row index of the original matrix. Now we can consider the program example for this one. Okay, by following these two principles we can implement the program here. Okay, so here we have the program. Here we can enter the row and column size. Then we can enter the elements of our elements of our matrix, and the input matrix is named as A. Okay, so the values are read and stored using this particular loop. So after that the entered or the matrix is displayed in the matrix format using the second loops. Okay, after that, now we can find the transpose, right? For that we can use the same loop set and make certain changes over it. Okay, so what are the two conditions we need to follow in order to get the transpose? We need to change the row with the column dimension of our input matrix. So I equal to 0, I less than c, I plus plus, and j equal to 0. Here we need to change this c with the row size of our input matrix. Then while printing, we need to interchange the dimension of our row and column. That is, the row index become the column index, and this column index become the row index. Okay, now we can display our transpose matrix. So we can give some command here, printf /n transpose matrix. Okay, okay, now we can execute this. Okay, enter the row and column size of the matrix. We can enter the same row size equal to 2 and column size equal to 3 with numbers 1, 2, 3, 4, 5, 6. Okay. Okay, the row size equal to 2 and the column size equal to 3, and the numbers are 1, 2, 3, 4, 5 and 6. So the input matrix is 1, 2, 3, 4, 5, 6, and the transpose matrix is 1, 4, 2, 5, 3, 6. That means the first row become the first column here, the second row become the second column here. Okay, so for more clarity we can put a space here and execute this once more. The same, 2 row with 2 columns. The elements are 1, 2, 3, 4, 5, 6. Okay, the input matrix is 1, 2, 3, 4, 5, 6. This first row become the first column here, second row become second column here. Okay, so what are the changes we have made here? We need to interchange the row size with the column size of our original matrix, and the column size with the row size of our original matrix. And while printing, we need to change the index of different values. So the I index become j here and the j index become I here. Why? We need to interchange the index of each and every element in our transposed form. That is, in the original form, the I index become the jth index here in transpose form. Okay, that means the row index become the column index here in the transposed form, and the column index become the row index in the original form. Okay, so this is the program for finding the transpose of a given matrix.